Seasonal relatives are a set of numbers that express consistent seasonal variation in data. Seasonal relatives can be used in forecasting. That is exactly the situation here, but why? How is it that you actually use seasonal relatives? It's generally a situation that's like this. Marion County has just renewed its contract for non-emergency medical transportation with Livingston Medical Services. The director of van transportation learned that Marion County expects now notice this. Let me get kind of a highlight color. Expects a total number of clients to increase to 14,500 by the start of the year. You say, okay. Using the regression equation developed earlier in scenario 2A, the director forecasts a total of, now see the 1400, that's how it got used, got plugged into the regression equation, 1,481 requests for courtesy van transportation next year. All right, so what has happened here is that we have a quote for the number of clients, and using a regression model from earlier, the manager has come up with a forecast for the number of courtesy van transports. And you go, yeah, okay, it sounds like they have it all under control. That number, the 1,481, that's for the whole year. You say, oh, yeah, okay, so what am I supposed to do? Well, like it says here, approximately how many requests for transportation can Livingston expect each month? This is typically how seasonal relatives get used. To take a larger forecast, some tool was used to create a larger forecast, like an annual forecast, and break it down rationally across smaller periods, the seasons. Because we remember Livingston Medical Services that the demand for courtesy van transportation tends to be much higher in certain months than in other months. We had seen that. Now we have this overall annual amount, but very naturally we're going to now want to know, well, what does that mean about January versus May or July? Okay. Here's what we do. First off, what we do is simple and perfectly rational. Take the annual, the big forecast, if you will, the one that needs crunching, 1,481, and come up with an early estimate for each month by, divide by 12. There's 12 months in a year. I get 123.4. And you say, all right, well, there's an early estimate for January or May or whatever, about 123.4 courtesy van transports. Except wait, we have a term for that number, the 123.4. What I did was I took the annual forecast and I divided by the number of seasons, because here seasons are months. That means that I'm basically assigning the same number of courtesy van transports to each month. We call this number deseasonalized. It is a deseasonalized. Yeah, deseasonalized. That's what I was trying to write. Why? Because it's naive of the fact, and we had already seen this in an earlier scenario, that January tends to be a very busy month for them, and summertime months tend to be very, very quiet. This estimate of 123.4 is treating all the months as the same, and it's naively assuming that there'd be the same number of courtesy van transports each month, and we've seen this before. We know that that's not what's going to happen. What we want to do is we want to now introduce the influence of the seasons. Okay, you say, well, how do we do that? It's actually really, really simple. We multiply. Okay, to seasonalize, you multiply by the appropriate, let's see if I can spell that right, appropriate seasonal relative. And what was asked here was that we do this for each and every month of the upcoming next year, okay, we're going to need a little bit of room to work then. Because I've got the note frame, there is some room to work. We need to perform that operation, if you will, and come up with a separate forecast for each month out of the year. I'm drawing some lines just so that my numbers stay a little bit neater. See, July, we'll need a forecast for August and a forecast for September. We'll need a forecast for October and a separate forecast for November and a separate forecast for December. Okay, what will the forecast be? We're going to begin with the 123.4, right? The one that I said was naive of the seasons. Because, for instance, in January, we said, all right, we'll begin with 123.4. Of course, that's innocent of the fact that January tends to be a busy month. So multiply this number by 1.92. You say, what? Do you remember that? That was the seasonal relative specifically for January. We had found that out in an earlier analysis. This is what we use that number for. Okay, so actually what I get on my calculator is like 236.928, which doesn't make any sense as far as recommending van transports. So notice it says here to the nearest integer. We will say actually for January, notice this, based on the annual forecast of overall, there'll be about 1,481 requests for courtesy van transport. We're going to estimate that 237 of them will be in January, because January tends to be a fairly busy month, as opposed to February. Begin with the same innocent number, 123.4, multiply by the seasonal relative for February for Livingston Medical Services is 1.08, which means that our forecast will be 133 courtesy van transports. For March, the same 123.4, but for March, the seasonal relative is 1.01, so we're going to forecast even fewer requests, only 125. For April, it's the same 123.4 times the seasonal relative for April is 0.88, so the forecast is even lower for April, 109. For May, begin with the same 123.4. Multiply by, for May, the seasonal relative was 1.50, which means our forecast for May, based on this information, is only 60, because we know that the demand for courtesy van transport naturally starts to slow down in the summertime. For June, 123.4 times 0.47 was the relative for June, so even fewer in our forecast, well, slightly fewer, 58. For July, 123.4 times the relative for July was 0.48, so we will forecast 59. For August, start with the same 123.4, multiply by August's seasonal relative was 0.55. So our forecast will be rounded to the nearest integer, 68. For September, 123.4 times 1.14 was the relative for September, so we will forecast nearest integer 141. Notice that our forecast is now picking up as we move into cooler months. October, 123.4 times the relative for October was the biggest one of the whole set when we found this original set, 2.4. We are forecasting a very busy month, 252 van transports in October alone. In November, 123.4 times the relative for November was 1.41, so 174 will be our forecast. And then in December, 123.4, always the same number to start, times December's relative was only 0.5. So we're going to forecast that it will get quiet again. around the very, very end of the year, we're going to forecast 62 courtesy van transports. This is how we use seasonal relatives to seasonalize data. Typically, you are seasonalizing data because you are trying to create many smaller forecasts, January, May, December, from one larger forecast.